So just a reminder, it's always good to go through this. You do need to understand how to do this, and you will need to know this skill. And probably starting next week, I'm going to throw out some other things to do with radicals, but for now, let's just simplify. So what I can approach this different ways. I'm going to approach this maybe one way that you could have done it. And you might have been able to figure out that 80 is the same as 4 times 20, which becomes the square root of 4 times the square root of 20, which becomes, when you take the square root of 4, that becomes 2 square root of 20. Now that is pretty good, and you can see that's one of our answer choices. So if you answered B, that's good, but it's not the final answer. So that's why it's not actually the correct one. Because we can actually dive into this a little further. We could look at 20 that's still under the radical and realize, you know what, that 2 is still there, first of all. That's just the same as 4 times 5. And that means the next step would be 2 times the square root of 4 times the square root of 5. I can just separate, divide them, and give them their own radicals. And then the square root of 4, again, is just 2. So that's 2 times the square root of 5. That's what that becomes. And your final answer here is 4 square root of 5. D is the answer, and most of you had that one correct. Now, you could have done it just really quickly a different way. You might have immediately figured out that 80 was just 16 times 5. And if you're able to do that, then it's a much shorter process, because you can just say the square root of 16 times the square root of 5. And I know the square root of 16 is 4. And there it is. So it doesn't matter if you went kind of the longer route to get there, or if you kind of did the shortcut. The only thing that matters is that you're able to keep simplifying and you found your final answer. Okay, so today we are going to review what was in the video. And remember, yesterday you were supposed to watch that video. And the way you access the video, because I got this question, you're supposed to go to 127 class in Canvas. And in there's a video, about a 20-minute video you're supposed to watch. Hopefully everyone here today watched that video and is feeling pretty good about what was covered yesterday. We are going to briefly go over it, but then we're going to basically just get some more practice today. On Monday, we're going to introduce some more rules, but I'll kind of repeat myself with that information later. So these are the kinds of questions. I'm actually not going to do these 2 problems because these are 2 of your homework problems from last night. So I'm not doing these right now, but these are the kinds of problems that you need to be able to look at and solve. Now, I will say this now, and I might say this again later. If you have homework problems that you do not know how to do, here's the idea. You look at the homework, on the night that it's assigned. You come to class the next day and you say, Mr. Davis, number 21, I cannot figure that one out. This one right here. And then I'll sit and work with you and we'll solve it together. It's not like you can't get help on these. I just want you to try it first. And then if you don't know what you're doing, certainly come to me and we'll sit there and we'll go through the entire homework together if you need to. So just remember that. These are the kinds of problems. We're going to see some more of them today. And the rules that we need to know in order to do that, this was again from the video, so I'm going to do it very briefly. We learned 5 rules, but one of them I'm going to kind of ignore to some degree because it just doesn't come up very often. So the first one we learned was if you have 2, actually I'm going to do this in a different color. All right. If you have 2, those are supposed to be 2 lines. I'm going to try and make it a little bit straighter. Sorry. There we are. If you have 2 lines or segments that intersect each other, the opposite sides of these are called vertical angles. All right. Not only that, actually I should do that in the same color. So these 2 are called vertical angles. And we think of vertical as something that's sitting upright, but that's not how we mean it in this case. We just mean that these are angles that are opposite from each other at an intersection. All right. Now these 2 angles here it's another pair of vertical angles. All right. So we've got 2 pairs of vertical angles at every intersection of 2 lines. And notice that the symbols I'm using, these arcs, I can kind of do 1 arc or 2 arcs to distinguish which ones are congruent. So the red angles are congruent. And the way that I would want to write this is the measure of angle, if I call this A, B, this can be C and D. If the measure of angle A equals the measure of angle B, then by extension, we can say that's also true the other way. Measure of angle C equals the measure of angle D. And that's what that notation means. Okay, so that was the first rule. The second one I don't want to spend much time on. This is if we have adjacent angles, and that means they share the same vertex right here. I'll call this A, B, C, and D. And I've got three angles here. I've got this angle, and I'm going to name them in a second. I've got that angle, and then I've got this angle. So I can say that the measure of angle ADB, notice that the D in the middle is my vertex. And you can follow those points, ADB, that angle right there, that angle plus the measure of angle BDC, that's going to equal the measure of angle ADC. Okay, and that's this big angle right here. If you don't understand it as I'm going through it briefly, you can watch the video to get a better understanding. All right, but we're saying that this small angle, let me do it this way. This small angle here plus this small angle here equals the bigger angle right there. That is the angle addition postulate. It's actually not something that we use a lot. So I'm going to write off to the side what these are. So this is vertical angles. This is angle addition postulate. And the next one we're going to look at is called linear pairs. I'm just going to put LP. So if I have any kind of intersection going on, these two angles right here, I'll call this one A, and I'll call this one B. These two angles are going to be supplementary. They add up to 180 because they're two angles that add up to a line. So measure of angle A plus the measure of angle B equals the measure, or sorry, equals 180 degrees. And I'm going to have you guys jump in and help create some equations today. So it's going to be a more interactive class. So be prepared to kind of chip in. I just underlined to show that, where the angles come from. All right. So the next one we're going to look at is called angles on a line. And this is very similar to the last one we looked at. But imagine you have a lot of angles coming off of one line. So I've got, A, B, C, D, and E. All of these angles, I can say measure of angle A plus ... plus the measure of angle E. So that means basically all those angles added up will equal 180 degrees because they're all creating a line. I'm trying to draw the degrees. Doesn't want to work for me. Okay, it's too close to the edge. It won't let me mark the degrees. But all those angles add up to 180 degrees. Okay, and the very last one that we saw yesterday was angles at a point. And this is one that's a little bit different from the others. So imagine you just have a point right here. And then from there, it radiates a bunch of different angles. And none of these are supposed to be straight lines. It's just, all these are just rays coming off the side or segments. It's not two straight lines intersecting each other. So now I've got all these angles right here. A, B, C, and D. And here's the basic idea. All these angles, because we're going around a point 360 degrees, all those angles have to add up to 360. So measure of angle A plus the measure of angle B plus the measure of angle C plus the measure of angle D all add up to 360 degrees. All right. So if you want to have this reference available to you, you can go into the Canvas class, and in yesterday's class, there's the 127 activity. If you did everything yesterday, you would have already pulled that up probably and seen it, or you would have at least know where to find it. So those rules are, there is a reference that reminds you of what they are. But I'm going to go ahead and erase this, and we're going to move ahead. Are there any questions before I do that? Okay, then. Let's practice with some of this. All right. So we have this diagram given. It asks us to find the measure of angle TRV. So the first thing I want you guys to do, and just anyone or everyone can do this, I want you to go ahead and draw an arc on here where angle TRV is. Here's the 52, so I'm going to draw an arc for that one. But if you could draw a similar arc where TRV is. There it is. There it is. Okay, so when it says TRV, notice R is going to be the vertex. So I'm going to start at T, come down to R, then go over to V, and that's it. That's how we find that angle. All right, so what I want you to do, we learned something here that when you have, well, maybe we could name this real quick. Actually, I need to set something up at the bottom. Sorry, it's a little bit hard to read. That's vertical angles right there. I'm going to write down angle addition postulate, but then I'm going to cross it out. We're not going to use that one today. And then we've got linear pair, angles on a line, and then angles at a point. So what I want you to do is I want you to circle which one of these rules is going to apply for this particular problem. You can either circle it on the screen, or you can just turn your mic on and say it. So there it is. We've got vertical angles that was circled, and that's exactly what we're looking at here in this diagram. They are vertical. So now we can say this. I'll fill in the left side, the measure of angle TRV, but actually later I'm going to have you guys fill in these blanks. What is that going to equal? Someone can write in on the right side what that's going to equal. So there we go. This is good stuff. So we've got these two angles, and I'm just going to write the measure of angle, SRU. That is correct, but we already know that this is 52 degrees. So there we go. This is a good one. We don't even need to do any calculations. We just say it equals 52 and we move on. Okay, so we will move on to the next one. I'm just going to get ready. So next problem right here, the first thing I want you to do is identify where angle HKI is. You can just draw an arc for that. Very good. So we've got we've got angle HKI marked here. You can see H down to K over to I. So the next question is, which rule are we going to use in order to solve for the measure of angle HKI? All right, so let's start looking through this. We got a thumbs up, so people agree that that is the correct rule to use here. So we've got this one point K in the middle. There we go. A number of people agree with this. Everyone's feeling good that we're on the right track. These three angles all kind of sit going around this point K. So that means these are angles at a point. and that is correct. We're going to now write out our equation. I will do this. All right, and what I want you guys to do is you can just pick and choose which blank you want to fill in, but go ahead and fill in these blanks with the numbers and notation that we need so that we can move forward and start doing our algebra quickly. So now that we've got 147 plus 133 plus measure of angle HKI, these added up all have to add up to 360. Now we can just combine our numerical terms. So the measure of HKI, when I add up 147 and 133, hopefully you've had time to look at that. It'll be 280. And again, just to run through this one kind of quickly so that we can make up for the time that we just lost, minus 280 on both sides. And then we're left with just the measure of angle HKI is, and that's where that 80 comes from. And again, you don't have to do this stuff in your head. That's why you have a calculator. You know, add up the 147 and 133 on your calculator. Subtract 360 minus 280 to get your 80 degrees. Okay. And there it is. Very good. Let me just erase a little bit so we can be ready. We don't have a whole lot of problems. I think there's maybe 2 more, and then we're going to call it good. I'll let you get to your practice. Okay. Same thing as before. First of all, draw an arc. Anyone can do this. Draw an arc for where angle DCE is. And at the same time, someone can circle. There we go. We have the arc showing the angle that we're looking for. Now we can look at which rule we want to pick. So which one is it going to be? All right. Yeah, if people's internet is acting up, I mean, mine just did, so I understand that. Do we know which rule we're going to be using for this problem? So I will say, if you are not sure how to pick the correct rule, then that means that you're not very comfortable with these, and you probably didn't watch the video yesterday. So I would highly encourage you to do that. When we have angles on a line, that means that we have 3 or more angles that all add up to a line. And that, of course, means that you have to add up to a certain number. So I'm going to have you guys create this equation. All right, so I just wanted to mention a few things, and luckily I didn't say anything, but you guys figured it out. This angle doesn't have anything given as far as a number, but like some of you noticed, it does have the right angle symbol. So we know that a right angle is 90 degrees. There we go. The other thing, the correct, I'll say the quote correct way of writing this would be the measure of angle DCE. But I will tell you this at the beginning. I'll erase what I just put down there. That right there, DCE, if I looked at this and you wrote that equation, that would look great to me. I would know exactly what you were doing. So when you're showing your work, you don't have to get worried that you accidentally didn't write your variable correctly. If I can follow your work and it's very clear to me, then you're good to go. So I don't want you getting caught up on like the tiny things. All right, so let's go ahead and do this. Fill in those couple blanks for the next step. Oops, I didn't mean to do that. Okay, so very good. All we did was combine our numerical terms from the previous step right there. And now we can come up with our final answer, and you can just write this down. What is the measure of angle DCE going to be? There it is. We got a couple people who wrote that down. It's funny, you guys end up kind of writing right over each other, and it works out really well. So minus 162 from both sides is what we did there. And you're good. 18 is, I'll just, to make sure it's really clear, 18 was the final measure. All right, very good. I will go ahead and bring up the next one while I'm erasing. Okay, and so you can start looking at this, but don't do anything on the screen just yet. So this one right here, we don't need to identify the angles. They're kind of already given to us. So we got a D right here and D right here. The measure of angle D, there's, anyways, you can see the diagram. What rule will apply for this particular problem? Angles on a line, this is actually pretty much the same problem we just had. There is a difference. So now knowing it's angles on a line, I'm just going to do this. Now, what you might not be comfortable with right now is knowing, there we go, we're starting to fill it in, that's really good. You might not immediately know, oh, it's gonna be three things added together to equal something, but hopefully with just some practice with this, it's kind of making sense. We've got those, there are three angles that add up to 180, so you can see that. What should the other two blanks have in it? Measure of angle D and? There it is. Yeah, the measure of angle D, we've got that twice. And we can see why. We've got two angle Ds right here, and then 182. So that's exactly what we have represented with all this. All right. So we're just turning this from a geometric diagram into an algebraic equation. And that's the key skill. So I'm turning this right here into this equation right here. And that might be the hardest part of this when it's all said and done, but hopefully it's not too bad. And if you're feeling comfortable with these 5 rules that we've got, again, really only 4 because we don't use that angle addition postulate as much. But if you're feeling comfortable with it, then you're in great shape. Okay, so the next step. You guys can fill in those blanks. So this might be something that some of you have something in mind, but you're not comfortable enough necessarily writing it. This is, we could think of these just as a variable x, an unknown. And if I just had 2 x's right there, I'd put 2x. Now, we use different notation for it, but it's essentially just an unknown variable. So at this point, what I can say is this is going to be 2 times the measure of angle D. All right, so that hopefully is where your head was headed, where your mind was going, but there we go. So now we can just kind of quickly move forward with this. I'm not going to take too long with this. We definitely want to solve this equation now. Even though it looks a little different with the measure of angle D in the middle of it, it's just an algebraic equation. So I'm going to subtract 82 from both sides. I get 2 times the measure of angle D equals 98. And what's the last thing we do?
You divide it by 2.
There we go. Let's divide both sides by 2. Pretty straightforward. The measure of angle D, I'll go ahead and cancel those out so we can see it, is going to be 98 divided by 2, 49 degrees. Okay. Again, you don't have to do any of this stuff in your head when it comes to the calculations. Use that calculator. Just make sure you're plugging the numbers in correctly. All right, last one for us to do. And I will go ahead and jump into that next one. So you can, oh, first you're going to raise your hand, let me know you're here. Okay, so the very first question, as always, I know this one's, at least on the surface, it looks a little different. It looks maybe more complex, but hopefully by the time we're done, you'll realize it's really no more difficult than anything else that we've done. So see if you can identify the correct rule that we should pick so that we can set up an equation. So we've got angles at a point selected, and I hope that this is obvious enough. Again, the point in the middle, none of these are labeled, so we don't need to worry about names of anything. But we can see all these angles go around 360 degrees, so I already gave part of this away. So let's go ahead and write this equation out. There's a lot of blanks on this one. So go ahead, jump in and start filling those blanks in. Okay, so there we go. That is the equation. And again, we know it's 4 blanks. Now, it's not always 4 blanks for something like this. It could be 3. But we've got 4 blanks because we can see we've got 1, 2, 3, 4 angles right here. So we're going to add all 4 of those up. And you guys did a great job transferring all these into the equation. Okay, so I'm just going to kind of do this a little bit shorter. And I want you guys to fill in those 2 blanks. See if you can figure out what the next step of this equation should look like. Yeah, you guys are doing a really good job of kind of getting the hang of it. And everyone who is not actually writing on the screen, hopefully you're still following along, maybe writing these examples down so that you can have an understanding of it, even if you're not comfortable enough sharing. All right, that's our next step. How about you guys just write in what the next step of this equation would be. Yeah, we got the x here. And yeah, if you could, if you're really good with your mental math, you could probably just jump through and do all that in your head. But yeah, we've got 3x once we subtract 120 from both sides. Now we can kind of do that last little bit. And I won't take any more time. You guys should know what to do. There you go. So I know that some of you were already jumping to the final answer. X here equals 80 degrees. And that's that. Okay. So just wanted to get some practice, kind of some step-by-step, getting you guys involved with this. I will now clear the screen. And now that is it for today in class. But if any of those problems you wanted to go over again, anything else, certainly stick around. Your homework in Canvas today is going to be, and I'll just go over there real quick. This will only take a minute, and then you guys can head off to practice with that. So there's no class for yesterday in Canvas. You'll see it go straight from Wednesday's class to today's. Your assignment is going to be, if you look at this, all of the problems that are in a red box. Hopefully this uploaded correctly. There it is. All of these problems in the red box, those are the ones that you need to do. So you can access it there, and then you can see right there. Let me know if you have any questions on the homework, but you can access it through Canvas and turn it in. And besides that, I'm going to stop sharing. You can have a wonderful day. If you have any questions, stick around, but otherwise, I will see you on Monday.